There is a place in the universe where time itself begins to break down, not slow down, not stretch, break down, a boundary where everything you understand about past, present, and future starts to lose meaning. Every second, your eyes are already looking into the past. The light from your surroundings takes time to reach you. A fraction of a second, but still the past. Now, extend that idea far beyond Earth. The light from the moon takes about 1 second to arrive. From the sun, it takes 8 minutes. From distant stars, it takes years. And from the most distant galaxies, it takes billions of years. This means that when you look deep into space, you are not seeing things as they are now. You are seeing them as they were long ago. Ancient light carries ancient moments. The deeper you look, the further back in time you travel. This is not science fiction. This is how the universe actually works. Astronomers use this fact as a tool. Powerful telescopes allow them to look deeper into space than ever before. And with every new observation, they are not just mapping distance, they are uncovering history. Entire galaxies appear frozen in their earliest stages. Stars are seen being born in slow cosmic time. Some of the light reaching us today started its journey before Earth even existed. But there is a limit to how far we can see. The universe is about 13.8 billion years old. Light travels at a fixed speed. Because of this, there is a maximum distance from which light has had enough time to reach us. This creates a boundary around us, a cosmic horizon. Beyond this horizon, there are regions of space that we cannot observe. Not because they do not exist, but because their light has not reached us yet. This is known as the observable universe. It is important to understand that this boundary is not a wall. It is not a physical edge you can touch or cross. It is a limit created by time itself, a limit of information, a limit of what the universe has allowed us to see since the beginning of everything. And here is where things become deeply strange. As scientists push closer to this cosmic horizon, they are not just exploring distant space, they are approaching the earliest moments of time. Near this boundary, galaxies appear younger, light becomes stretched. Signals become weaker. Time itself seems distorted through the lens of expansion. The universe is not just expanding, it is accelerating. This means that distant regions are moving away from us faster and faster. Some are moving so quickly that their light will never reach us ever. Those regions are not gone, they are still there, time is still flowing there. But for us, they are completely cut off, hidden beyond the boundary that keeps growing. So this leads to a question that changes everything. If the edge of the observable universe is the limit of what we can see in space, is it also the limit of what we can see in time? When we look as far as possible, are we witnessing the beginning of time itself, or is time continuing beyond that edge in ways we can never observe? The answer is not simple, and it is not intuitive. Most people think of time as something universal, something that flows the same way everywhere. A steady progression from past to future. But modern physics tells a very different story. Time is not absolute, it is connected to space, it bends, it stretches. It depends on motion, gravity, and perspective. At the largest scales, the structure of the universe itself affects how time behaves. Near the cosmic horizon, strange effects begin to appear. Light is stretched to extreme wavelengths. Events seem to slow down, information fades, it becomes harder and harder to define what now even means at such distances, and then comes the most shocking part. The edge of the universe might not be a place at all, it might be a limit of perception, a boundary created by the relationship between light, space, and time, a horizon that depends on where you are and how you observe. Someone in a distant galaxy would have their own observable universe, their own boundary, their own version of the edge, and it would not match yours. This means that the concept of a single universal edge may not exist. Instead, there are countless horizons, each tied to an observer, each defining its own limits of space and time. So when you ask what happens to time at the edge of the universe, you are not just asking a question about physics, you're questioning the nature of reality itself. Does time fade away as we approach that boundary? Does it slow down infinitely? Or does it continue normally in regions forever hidden from us? And if we can never observe those regions, can we ever truly understand them? In this video, you will discover how time and light are deeply connected, why the universe has a visible limit, and what really happens as we approach the edge of everything we can see. You will learn why time does not simply stop at that boundary and why the truth is far more unsettling than it first appears. By the end, your understanding of time will not be the same, because the real edge of the universe may not be out there in space. It may be in the limits of what we can ever know. Welcome to the channel. Subscribe now, because this is only the beginning of a much deeper journey into the universe. The phrase edge of the universe sounds simple, but it hides a deep misunderstanding. It suggests a boundary you could reach, a final point where everything stops. But that is not how the universe works. There are two very different ideas here. One is the entire universe. The other is the observable universe. These are not the same thing. The entire universe includes everything that exists, every galaxy, every star, every region of space, even those forever beyond our reach. It may be infinite. It may stretch far beyond anything we can ever detect. There's no confirmed edge to it. The observable universe is different. It is the portion of the universe we can actually see. It is defined by a simple limit. Light travels at a fixed speed. The universe has a finite age. Because of this, only light that has had enough time to reach us since the beginning can be observed. This creates a sphere around us, a vast region filled with galaxies, radiation, and ancient light. Its radius is about 46 billion light years in every direction. That number sounds strange at first. It is larger than the age of the universe would suggest. This happens because space itself has been expanding while light travels through it. Distances stretch over time. So even though the universe is about 13.8 billion years old, the observable region extends much farther. At the boundary of this sphere lies something called the cosmic horizon. This is not a physical object. It is not a surface. It is a limit set by time and light. Beyond this horizon, there are galaxies whose light has not reached us yet. Some of that light is still on its way. Some will never arrive at all. The expansion of the universe is accelerating. This means certain regions are being pushed away. Faster than light can close the gap. This creates a permanent barrier to observation. Those distant regions are still real. Stars are forming there. Galaxies are evolving. Time is passing, but none of that information can ever reach us. It is cut off not by distance alone, but by the structure of space-time itself. This leads to a powerful realization. The edge is not a place in space. It is a limit of information, a boundary of what we can know. If you traveled toward this edge, it would not behave like a wall. You would not crash into it. You would not see a line separating existence from nothingness. Instead, new regions of space would come into view as you moved, while other regions would fall behind your own horizon. The edge would move with you. This means every observer in the universe has their own observable universe, their own horizon, their own version of the edge. So the boundary is not fixed. It depends on where you are. And as we begin to explore what happens near this cosmic horizon, one thing becomes clear. The deeper we approach this limit, the more our understanding of time begins to shift in ways that are far from intuitive. Light is not just something that lets you see. It is a messenger. Every beam of light carries information across space and time. It tells a story about where it came from and when it began its journey. When light leaves an object, it does not arrive instantly. It travels, it moves at a fixed speed, the fastest speed possible in the universe. But even that speed has limits when distances become enormous. This changes everything. When you look at something far away, you are not seeing it as it is now. You are seeing it as it was when the light first left it. The farther away it is, the older the image becomes. A star that is 10 light years away is seen as it was 10 years ago. A galaxy that is 1 billion light years away is seen as it was 1 billion years ago. This means telescopes are not just tools for looking across space. They are tools for looking back in time. This is one of the most powerful and least intuitive facts about the universe. Some of the galaxies observed today appear as they were when the universe was very young. In many cases, less than 1 billion years old. These galaxies look different. They are smaller, more chaotic, full of intense star formation. They reveal a stage of cosmic history that no longer exists nearby. The light reaching us from these galaxies has been traveling for billions of years. It has crossed expanding space. It has stretched and shifted. By the time it arrives, it carries a record of an ancient universe. This stretching of light is known as redshift. As space expands, it stretches the wavelength of light traveling through it. The farther the light has traveled, the more it is stretched. This allows scientists to measure how far away something is and how long ago its light was emitted. So distance becomes a measure of time. But this connection goes even deeper. Space and time are not separate things. They form a single structure called space-time. This idea comes from modern physics and changes how we understand reality. Events do not just happen in space or in time. They happen in both, woven together. This means that when light moves through space, it also moves through time. It links distant events to the present moment. It connects the past to the now in a direct and measurable way. There is no way to separate the two as you observe deeper into space. You are moving along this fabric of space-time. Each distant object marks a point further back in cosmic history. The universe becomes a layered record of its own past, visible all at once from our position. This leads to a strange situation. Different parts of the sky show different moments in time. One region may display a galaxy as it was billions of years ago. Another region may show a closer galaxy in a much later stage. The sky becomes a mix of F timelines, all visible together. There's no single universal present that we can observe everywhere. And as observations push closer to the cosmic horizon, the light becomes older, more stretched, and more extreme. It approaches a limit where it no longer carries clear information, where time itself becomes harder to interpret through the signals that reach us. As observations push deeper into space, something begins to change. The universe does not just look farther away, it starts to look older, dimmer, and more distorted. The galaxies near the edge of what we can see do not appear like the ones close to us. Their light has traveled for an immense amount of time. During that journey, the universe has been expanding. This expansion stretches the light itself. This effect is called cosmic redshift. Light that once started as visible radiation shifts toward longer wavelengths, first into red, then into infrared. And for the most distant objects, it stretches so much that it becomes nearly undetectable. Some of this ancient light has wavelengths thousands of times longer than when it began. This means the farther we look, the harder it becomes to even detect anything at all. Powerful instruments can still capture faint signals from the early universe, but there's a limit. At extreme distances, the light becomes so stretched and so weak that it blends into the background. It fades into silence. But the changes are not just about light. Time itself appears to behave differently. When scientists observe distant cosmic events, something strange happens. Processes seem to unfold more slowly. Explosions take longer. Variations in brightness stretch out over time. Everything looks as if it is happening in slow motion. This is not an illusion. It is a real effect. Because the universe is expanding, the intervals between light signals also stretch. If a distant event emits pulses of light at regular intervals, those intervals arrive at Earth stretched out. Time, as seen through that light, appears slowed down. This is known as time dilation caused by cosmic expansion. The deeper the source lies in space, the stronger this effect becomes. Near the cosmic horizon, this stretching becomes extreme. Events that once occurred quickly in their own frame of reference appear to drag on when observed from far away. So the closer we get to the edge of the observable universe, the more time itself seems to lose its normal rhythm. At the same time, the signals we receive become weaker. Light spreads out as it travels, its energy decreases. Combined with redshift, this makes distant objects incredibly faint. Detecting them requires extreme precision and long observation times. Even then, what we see is incomplete. There comes a point where signals become so weak that they disappear into noise. They can no longer be separated from the background radiation that fills the universe. This radiation, known as the cosmic microwave background, is itself a relic of the early universe. It acts like a curtain, limiting how far back we can see with clarity. Beyond a certain distance, light is not just faint. It is effectively gone from our perspective. This creates a gradual fading of information. There is no sharp boundary where everything suddenly stops. Instead, there is a slow transition. Clear signals become distorted. Distorted signals become faint. Faint signals become undetectable. The universe does not end. It simply slips out of view, and as this fading continues, a deeper question begins to take shape. If time appears slower and information becomes weaker as we approach this limit, does time itself actually come to a halt at the very edge? Or is something else happening beyond what we can observe? It may seem natural to think that time slows down. No more and more as we approach the edge until it finally stops. The signals stretch, events appear frozen, light fades away. From this perspective, the boundary can feel like a place where time itself comes to an end. But this idea is misleading. Time does not stop at the edge of the observable universe. The appearance of slowing time is not a sign that time is breaking. It is a result of how information reaches us. Everything we know about distant regions comes from light. When that light becomes stretched and delayed, it changes how we perceive events. It makes processes look slower, it makes signals weaker, but it does not change what is actually happening in those distant places. In their own frame of reference, time continues as normal. Stars still burn, galaxies still evolve, new structures still form, nothing freezes, nothing pauses. The flow of time remains steady just as it does here. The problem is that we lose access to that flow. As the universe expands, space itself stretches. This is not like objects moving through space. It is space growing between objects. The larger the distance, the faster this expansion becomes. At great enough distances, this expansion becomes extreme. There are regions of the universe that are moving away from us so quickly that even light cannot overcome the growing distance. This does not break any laws of physics. The speed limit of light applies to motion through space, not to the expansion of space itself. So space can expand in a way that separates regions faster than light can travel between them. This creates a powerful effect. Light emitted from those regions will never reach us, not in billions of years, not ever. The distance grows too quickly, the signal is lost before it can cross the gap. From our perspective, those regions slowly fade out of existence. Their light becomes more redshifted, their signals weaken, eventually they disappear completely from observation. It looks like time is freezing at the edge, it looks like events are slowing to a stop. But this is only because the signals carrying information are being stretched and diluted beyond detection. The reality is very different. Time continues without interruption. It continues in regions we can no longer observe. Entire galaxies pass beyond our cosmic horizon while still evolving in full detail. They do not vanish, they simply become unreachable. This leads to a striking fact that is often overlooked. Parts of the universe that we can see today will not always remain visible. As expansion accelerates, more regions will cross this horizon. Future observers, billions of years from now, will see a much smaller universe. Many galaxies that are visible today will be gone from their sky. The observable universe is not fixed. It changes over time. This means the boundary is not a place where time ends. It is a shifting limit of visibility, a moving line between what can be known and what is forever hidden. And beyond that line, time continues to flow, completely unaffected by our inability to witness it, raising an even deeper question about what truly exists outside our observable reach and how much of reality remains permanently beyond our understanding. Beyond the edge of the observable universe, nothing suddenly disappears. There is no empty void waiting outside the boundary. There is no final curtain where existence ends. Everything points to a very different picture. The universe does not stop where our vision stops. The regions beyond our cosmic horizon are not special or different. They follow the same physical laws. They contain matter, energy, and structure. Galaxies form there just as they do here. Stars are born and die. Black holes grow. Time moves forward in a steady flow. From their own perspective, though, see distant regions look normal. The only difference is that their light will never reach us, not because it does not exist, but because space is expanding too quickly between us. The signal is cut off before it can ever arrive. This creates the illusion that the universe ends at the horizon, even though it continues far beyond. Some scientists believe the universe may be infinite. This means there is no edge at all. Space could extend forever in every direction, filled with countless galaxies and structures repeating in vast patterns. In such a universe, the observable region is only a tiny bubble within something much larger. This idea leads to a surprising possibility. If the universe is infinite, then somewhere far beyond our horizon, there could be regions almost identical to ours. The same laws, the same types of galaxies, possibly even the same arrangements of matter repeated over enormous distances. This is not fantasy. It comes from the mathematics of large, uniform systems. Other theories go even further. The concept of a multiverse suggests that our universe may be just one part of a much larger system. There could be other universes with different properties, different physical constants, and different histories. Some models describe these universes as bubbles, each expanding within a greater cosmic background. In certain versions of this idea, these universes never interact. They remain completely separate, forever beyond observation. In others, there may have been brief moments of contact in the distant past, leaving subtle imprints that scientists are still trying to detect. These ideas remain unproven, but they are taken seriously because they emerge from known physics. They are not random guesses. They are attempts to explain what lies beyond the limits of observation. And that is the key point. The edge of the observable universe is not a bounder. Why of existence? It is a boundary of knowledge. It marks the limit of what light has revealed to us so far. It defines what we can measure, not what is truly there. Beyond it, reality continues without interruption. Time does not slow. It does not fade. It does not end. It flows just as it does here, carrying events forward in regions we will never see. This creates a strange situation. There are parts of the universe that exist in full detail with their own history and future, yet they are permanently hidden from us. No signal, no message, no information from those regions will ever reach Earth. They are real, but forever unknown. And this raises a deeper issue about how we define reality itself. If something exists but can never be observed, how do we understand its place in the universe? And how does that reshape the way we think about time, space, and the limits of human knowledge? The edge of the observable universe is not just a boundary in space. It is a boundary in knowledge. It marks a point where information stops reaching us. Beyond it, reality continues, but it becomes silent. Everything humans understand about the universe comes from signals. Light, radiation, particles, these carry information across vast distances. They allow us to measure, compare, and build a picture of what exists. Without these signals, there is no direct way to confirm anything. This means our understanding of time is deeply tied to what we can observe. Time is not something we see directly. It is something we infer. We track change, we measure motion, we observe sequences of events. When those signals become weak or disappear, our ability to describe time also begins to fade. Near the cosmic horizon, this becomes clear. Events look stretched, light arrives slowly, patterns become harder to detect. The deeper the distance, the less clear the timeline becomes. At extreme limits, the sequence of events is no longer fully accessible. Pieces are missing, details are lost. So the question begins to shift. It is no longer just about what happens to time at the edge. It becomes a question of how we define time in the first place. In everyday life, time feels absolute. It moves forward at a steady pace. It seems the same for everyone. But modern physics has already shown that this is not true. Time changes depending on speed and gravity. It can slow down or speed up depending on the conditions. At the scale of the universe, this idea becomes even more complex. Different observers see different versions of time, and distant galaxy has its own timeline, its own sequence of events, Now, from our perspective, that timeline is stretched and distorted. From its own perspective, everything appears normal. There is no single universal clock that everyone shares. This leads to a deeper realization. The flow of time that we experience may be only one version of a much larger structure. It depends on where we are, how we move, and what signals reach us. Our view of time is shaped by our position in the universe. Even the idea of a present moment becomes unclear at large distances. Two events that appear simultaneous from one point of view may not be simultaneous from another. The universe does not provide a single shared now. This challenges a basic assumption. If time depends on observation, then the edge of the observable universe becomes more than a limit of sight. It becomes a limit of shared reality. Beyond that edge, events unfold in ways that are real but disconnected from our timeline. They exist in a sense that is physically valid yet permanently out of reach. This creates a gap between existence and experience. There are parts of the universe where time flows, where events occur, where history unfolds, yet none of it can ever be integrated into our understanding. It remains outside the network of information that defines our reality. And this suggests something profound. The true edge of the universe may not lie in space. It may lie in the limits of what can be observed, measured, and understood. A boundary not of matter, but of perception, As we push closer to that boundary, the question is no longer just about where time goes, but about whether our concept of time is complete or only a small piece of something far larger that remains hidden beyond the horizon. The edge of the universe is not where time ends. It is where our understanding begins to fail. Everything you have seen in this journey leads to one clear idea. Time does not break at the boundary. It does not freeze. It does not disappear. Instead, our access to it fades. The signals weaken, the information vanishes, and with it, our ability to track the flow of events. Beyond that edge, time continues without pause. Entire regions of the universe live out their own history, completely untouched by our observation. Galaxies evolve, stars rise and fall. Moments pass in full detail, yet none of it can ever reach us. So the boundary is not in reality, it is in knowledge. This changes how we think about time itself. It shows that time is not just something that exists on its own. It is something we understand through measurement, through light, through connection. When those connections are broken, time becomes harder to define. There may not be a single shared timeline across the universe. There may only be local experiences of time, each tied to an observer, each shaped by what can be seen and measured. This means the true edge is not a place you can travel to. It is a limit you can never cross, a horizon built into the fabric of space-time, separating what can be known from what will always remain hidden. And that leads to a final thought. The universe may be far larger than anything we can ever explore. Time may be far more complex than anything we can fully understand. What we see is only a fraction of what exists. The rest